Okay, perfect. So hi, everybody. I'm Lizzie, one of the Student Learning Hub coordinators at C2 Smart. Welcome to our second and last webinar of the fall semester. The Student Learning Hub is an education and workforce development initiative that offers applied learning and skill building opportunities to help you develop research and job-ready knowledge. And please feel free to raise your hand or ask questions in the chat during today's session. Today's course is Building a Scalable Multi-Threaded Processing System on AWS Cloud. This lecture introduces the design and implementation of a serverless multi-threaded processing system using AWS step functions, AWS Lambda, and Amazon S3. And the session covers how to orchestrate parallel tasks, manage state transitions, and scale processing pipelines efficiently on the AWS Cloud platform. Emphasis will be placed on cloud-native scalability, fault tolerance, and cost optimization through automation and serverless architecture. And today's instructor is NYU's Jeffrey Wang. He is a software engineer and developer assistant at the C2 Smart Center, where he develops AI-driven, cloud-based systems for intelligent transportation and urban mobility research. He previously worked at technology startups, building large-scale computer vision pipelines and automating AWS cloud infrastructures, and in investment banking, developing secure backend systems. And he holds AWS certified developer and solutions architect credentials and is pursuing his MS in applied urban science and informatics at NYU. And so now I'll hand it over to him.
Okay, cool. So, hi everyone. My name is Jeffrey, and I'm going to be today's speaker about the topic of building a scalable multi-threaded processing system on AWS Cloud. Okay, so let's start this. Okay, so first I'll share about today's agenda. We'll be first talking about what is AWS, what is Amazon Web Services, and also the cloud computing 101. And next, we'll talk about some AWS services. And after this, I will share about my project experiences on AWS Cloud of building this multi-threaded and processing system. And after all, we can have our Q&A session. Okay, so first, my name is Jeffrey, and my past experiences share across building some tech startups, tech companies, and I did some software engineering job at investment banking, and I'm also the cloud ambassador lead at AWS. And I had three different kinds of AWS certifications, include developer and solution architect. Yeah, and I'm currently a master's student at NYU Tana, master in urban science and informatics, and I did my CS computer science degree back in Taiwan. Yeah, okay, so let's get this started. First, I'm going to talk about what is AWS. Yeah, so what is AWS? Amazon Web Services is a cloud computing platform, which is a child company of Amazon. And this company provides the world's most comprehensive and broadly adopted cloud platform, and which is also the industry leader of the cloud industry, and offer over 200 different services and data centers globally, and used by millions of users to lower costs, become more agile in their development process, and innovate faster. Okay, so we're going to talk about how we can leverage AWS to reach these kind of goals, which includes a lower cost or agile development. Yeah, and before this, we're going to talk about what is cloud computing. So cloud computing is the on-demand delivery of IT resources over the internet with pay-as-you-go pricing. Yeah, so this is important. So we can do our software development on the cloud and with a pay-as-you-go pricing. And we don't have to like if we need a server, we need a server, we don't need to like buy the entire server and manage them. We just can host it on the AWS platform and we just pay the amount or the data we use. Yeah, and instead of owning, we can maintaining physical data centers and servers, and we can access technology services such as computing power, storage from the cloud provider. Yeah, and from this image, we can see that there are multiple different cloud providers, including AWS, Azure, which is from Microsoft, and Google Cloud, which is GCP, and other cloud providers. And we can see that AWS is the most well used and the industry leader of the cloud computing industry. Yeah. Yeah. And in the cloud computing industry, we can have different services, which is like SaaS, which is SaaS. It means software as a service, like a Google Workspace. Like we use like Google Meet, we use Gmail, we use Google Calendar, these kind of online software every day. These kind of services is called software as a service. Yeah, and differently from software as a services, on AWS cloud, we can uh, it provides infrastructure as a service, and also platform as a service, and also service as a service, software as a service. Yeah. So on AWS, we can manage our own infrastructure, platform, or software usage. Yeah, so what is cloud computing actually? So there's two core feature and core benefits we can have from cloud computing. The first one is on the on-demand usage, and the second one is scalability and availability. Yeah, so let's say we're going to have a Taylor Swift concert. Yeah, and as we all know, the Taylor Swift concert is super hard to get a ticket from this concert, right? So, if we are selling the ticket online, we're hosting a ticket website. So on the selling day, there will be a bunch of requests from worldwide or national requests to this website, right? But uh, what if we host our website local or on our own server? We let's say we have 10 servers for this website. But what if there's like some a huge request, a huge re amount of requests, and our servers can handle all these requests. Uh, so the result will be our website will be down, right? So how do we solve this problem? How do we solve this issue? So the solution is we can host this website on AWS or this kind of cloud computing platform. And whenever we discover a high amount of usage of this website, we can like we can scale up the computing power and also the uh, data storage, like database base or something else. And with this scalability and availability, we can uh, successfully handle our website when facing a large of requests and usage. Okay, so next is who use cloud computing. Yeah, and there's a lot of different usage across the globe, which includes general users, small business and startups, and also enterprise level usage. Yeah, okay. Yeah. There are some well-known AWS users like such as Netflix. So Netflix they use AWS services to host their their large video, large internet files on AWS to achieve a significant speed and like content streaming. Yeah, and also United Airlines and other huge companies, they host um, their software and their internal database on AWS. Yeah, okay. And we're going to talk about some cloud architectures for the cloud users. So with cloud computing, we have no infrastructure provisioning and no management. We don't have to like manage our own server, like the physical server. We don't need to uh, um, handle it by ourselves because AWS will handle all these service uh, for us. Yeah, and also au- automated scaling, we can like set up the auto scaling on AWS, and whenever we reach huge amount of usage, and also we can pay for each value we produced. So every connection, every data usage, every each computing power we use, we only pay for that. We don't pay for anything else, and that can make help us reach a lower cost of on software development, especially and within the startup industry. So that's the reason why the startup across the globe they use they depends on AWS and cloud computing services heavily, and we can have our highly available and secure architecture on the cloud computing platform. So AWS, we can set up our like backup system or backup storage on AWS, and the cloud computing platform will handle our backup system for us. And also, they will manage the security and the permission for us. Yeah, so here are the core benefits of cloud computing, which are the lower total cost of ownership, and also focus on the developer can focus on our own application instead of configuration. Yeah, and then we can build microservices applications that helps us to streamline our development process. Okay, so here are some AWS services. Yeah, as I mentioned, AWS provides over 200 different kinds of services, and yeah, across the cloud. And here are some famous and well-known AWS services. So for the computing power, we can have AWS Lambda function and AWS Fargate. And there's another uh, um, popular service called AWS EC2. Yeah, for the computing power. Yeah, and for the storage, we'll have Amazon S3 and Amazon EFS for uh, different kinds of data storage. Yeah, and so different than the storage, we have our database services. We can have our SQL and NoSQL database and host it on AWS cloud with the Amazon Dynamo database and which is for the um, SQL database. And Amazon Aurora database is for the NoSQL database. And we can have our RDS for the database proxy. And then Next on is the API proxy. We can host our API gateway on AWS and to manage our inbound or outbound um, internet function or our uh, inbound and outbound data. Yeah, to ensure the software security. Yeah, and we can have our application integration uh, for like queuing services and such as either Amazon SNS, AppSync, SQS, and even Bridge. These are very useful tools and services to host our data and our software. And then we can have our entire software workflow on our orchestration services, which is AWS Step Function. Yeah, and after we have all these kind of software components, we can do our analytics services such as Amazon Kinesis to analyze our data stream and Amazon Athena uh, to do some analytics on our data streaming services or logging and auditing services. Mm. Okay, so okay, so since we have a basic understanding on AWS and some kind of services, I'll walk uh, everyone through the details about some popular and famous AWS services. Yeah, so the first one is AWS Lambda function. Yeah, so this service is you can imagine that you have a Python script, Python program. You are running this Python program locally on your laptop or your own computer. So what we can do is, uh, let's say we're running this Lambda function like every day. Uh, yeah, and so what if we turn our laptop off? So this Python program will be turned off as well, right? So could we solve this problem if we wanna uh, have this Python program like running like every day, like 24/7? How do we achieve this? We can host this Python program on the cloud computing platform on AWS with our AWS Lambda function. Yeah, so this service can help us like host our um e- every kind of programming language program on cloud computing platform. And we don't have to care about the service, or we don't have to care about our own devices because it's running like 24/7 on the cloud. So we can like we can reach our service, we can reach our program as long as we have internet connection. Yeah, and yeah. So this is the serverless compute service. We can run our program without managing servers. So what is serverless actually? This word means that we don't have to care about the physical server that actually runs our program. We just need to focus on our core program and the development process. Yeah, and so how do we um, host our program on AWS? There's just like a website on AWS, and we can just copy paste our entire Python script on this AWS Lambda uh, console. And that's pretty simple. We don't have to care about anything else. Yeah, and the core benefits is that we only pay for round duration. So if we were running AWS Lambda function for our Python program, so like let's say we're running like 2 days a week, we're only like paying for those 2 days where are running for that service, and we don't need to pay other like costs. Yeah. So if you are running this program on your local server, so you're going to pay for the physical server, right? You're going to buy a physical server, and you're going to pay for the power usage, the electricity of the this server. Yeah. So this will uh cost us a lot of different kinds of time and money, right? Okay, so. Next on, we'll talk about the orchestration um, workflow, which can be done by AWS step function. Yeah, so in this AWS, you can think about that AWS step function is a uh, comprehensive workflow on AWS. You can define your own structure, and you can define your own components, which could be consists of AWS Lambda function, database or storage or API gateway. You can define all your services inside this framework. Yeah, so this is a simplified workflow orchestration, and and it is also an automated process and predefined process. So whenever you trigger this process, it will like run down all these workflow you predefine. So this is an automated business critical process, and we can also scale the this workflow with ease. Yeah. Okay. So next on, I'm going to share about the AWS project. Yeah. Okay. So this is a software framework and workflow of my project. So look into this image, we can see that the API gateway is my software's front door. So every internet request will come to our my front door to reach my entire software system. Yeah, and my entire software is hosted on the AWS cloud. So each of the internet requests will first reach the front door and will be directed to AWS cloud. And finally, within the AWS cloud, they will reach my core system. Yeah, and so inside the AWS cloud, I leverage AWS Step Function to design a workflow for my software. Yeah, and inside this Step Function, we have multiple Lambda functions. Okay, so before this, we can talk about what is this project. So this project is built for downloading and handling large internet files. So let's say we have like large videos like such as like movies or like large videos for like like detection or like vehicle videos. Yeah. So uh my task was to um uh whenever I have a link to this video, my task was to download the content of this internet link to the final destination, which is the Amazon S3 storage bucket. Yeah, so I have to download the content to the Amazon S3 storage. Yeah, so the challenge is those requests and those content are super huge, and that would take me forever to download these kind of like 10 GB or like 100 GB files to Amazon S3 storage. That could take me like forever to download these kind of large files. So um, the challenge is there, and my task was to streamline the downloading and handling process and improve the system efficiency to reach a significant reduction on this downloading process. Yeah, so as you guys can see, I developed a structure and system on AWS to leverage multiple AWS Lambda functions. Okay, so what are these AWS Lambda function used inside this project? So let's say we have our first request to download 10 GB internet files to our destination. So with our native approach, we just like download the entire 10 GB files to our storage, and that could take us like 10 minutes or like 20 minutes, right? Depends on where the where this internet files are are being stored. Yeah. So it could be sorted by um international users. We're like so this product so we're I'm sorry, our program is running like within United States, but this request may come from Asia, come from Europe. That will like makes us take take us like more time to download this internet file. So within my approach, we leverage multiple AWS Lambda function to reach a significant reduction. So how do we do this? So when we have a single request, this 10 GB file first, we just like break down this 10 GB file to like multiple parts. And this solution is also called divide and conquer within like computer science uh, knowledge or computer science concept. Yeah. So we first break down the 10 GB file into multiple slices and parts, and we uh, download these different parts separately. And after all, we can merge them at the end. And and with this approach, we wish we can achieve um, uh, a better performance within the system. Yeah. So the AWS Lambda within this project is for file processing and handling different parts of the content. Yeah, and Amazon S3 is our final destination, which is the storage bucket. Yeah, okay, so let's take a look about let's take a look into the set function workflow. This is a detailed set function workflow, which you can see every step within the workflow. And we manage the entire uh, orchestration on AWS set function. Yeah, so we can see that we start from here. This is the starting node of the entire software. Yeah, Um, so starting here, we can have our initialize step to initiate my entire workflow. And next step here, configure count, is that I'm going to count how many requests that is coming. like we have 10 requests or we have like 1,000 or 100 requests. That and that decides that how many loops we're going to have in our set function. So if we have 10 incoming requests, we're going to have 10 iteration in our process. Yeah, okay. And next, starting here, we have our iterator. So let's say we have 10 iteration. So the first loop we will have in here is like our first iteration, right? So the count isn't reached our target iteration. So we will turn right to our for processing. Yeah. Okay. So here is the first processing part. So we first send a HTTP request to this link. Okay, let's say this incoming request uh, contains a movie, which is a 10 GB movie content within this HTTP link. Yeah. So after we have this HTTP link, we can like just first send a HTTP request the headers to this link to get the entire content size. We're not going to have the entire content right now. We're just going to send a request header to get the size of this content. Yeah, okay. So next, after we have the content size, we can divide the content size into parts. Okay, so let's say we have 10 GB files uh, content within our link. So we can divide the 10 GB into 10 parts. Like the first part would be 0 to 1, right? And the second part will be 1 to 2 inside the content. Yeah, yeah, and until our entire content is are divided into 10 different parts. Yeah, so here, before all these are predefined workflow within the set functions. Yeah, the set function framework. And you guys can see the sort branch, we can have our 10 branches. So in this part, these 10 branches are all designed and passed on AWS Lambda function. Yeah, so we just have 10 different Lambda functions running our code, our Python script to download all the content file. So within each Lambda function, which within each node, it will run the Python script to download the file content that only that part of file content. Yeah. Okay. So after the 10 parts are finished all their downloading process, we will have the merge file, which is another Lambda function with a different script. In this script, we um we merge 10 different parts of the content within a file and upload it to the S3, which is our destination target storage. Yeah, and that means we finish the first um request. And we will go back to the iterator to see whether we have other requests. Yeah. Okay. So this is the main structure and main workflow of my project that hosted on AWS cloud computing platform. Yeah. Okay. Let's look into the performance of this um, approach. So if we're downloading and uploading a 2 GB file to S3, that could take us like 20 minutes of it of only a 2 GB file to S3. Yeah, that so if we're going to have like multiple huge internet requests, that could take us forever to finish all these tasks. Yeah, and so with this approach that we develop on AWS, we can have we can reach only 2 second performance like handling the same 2 GB file. Yeah, and we can see our system scalability if we have if 5 GB file to do the same task. We, we only we only need 1 more second to complete this entire task. Yeah. So yeah, so this is super powerful, and this performance is amazing. Yeah, and within this performance and these kind of metrics, we can uh, have a glance about the uh, power power of cloud computing systems. And that's why, and that's also the reason uh, the startups and also the huge companies they depend on cloud computing platform heavily because of the performance, because of the scalability and availability. Yeah, yeah, and that's my overall project. And here we can move on to the Q&A session. If you guys have any kinds of question regarding the project workflow or the project details, or you guys want to learn more about the AWS platform, yeah, just feel free to ask a question.
Or if you have a question, you can either type in the chat box or just simply unmute yourself. Okay, I actually have a question, Jeffrey.
Yeah, cool.
Um, I saw, and I'm just curious about the certificate for AWS. And maybe can you maybe give a little bit more information to the student and people in this room of, how to like apply for a certificate and how that process looks like?
Yeah, of course. That is the okay. So AWS they provides a bunch of different certifications in different specific areas, including artificial intelligence, AI, machine learning, and also software developer or solution architect, which is for like building system on cloud computing, and they call it a solution architect, and also database specialty or security uh, uh, s- uh, uh, experts, yeah, and also generative AI professionals or machine learning and networking uh, professionals, yeah, and there are a bunch of different certifications on AWS. So if you are into it and just look up to the certification page, and yeah, and these kind of certification are popular for the software developers and software engineers, and because in these days we most of our products or software are developed on based on AWS cloud or other cloud computing providers. So this is yeah, so this could bring a lot of benefits to the company if you hold different kinds of um, AWS certifications. Yeah. So if you're into it, you can um, possibly start from the AWS Certified Cloud Practitioner, which is a entry level certification, and it's about to some question that will test your basic knowledge about cloud computing or some entry level development process or tools. Yeah, and after you finish this, you can go to the associate certifications, which includes different kinds of specialties, including machine learning, developer, and or data engineer stuff. Yeah, yeah. And there's some more uh, professional certifications um, you can pursue in your career. Yeah.
Awesome, thank you. And I don't see any other question from the chat, so I guess we can conclude the session here. And as Lizzie introduced at the beginning, this is the last Student Learning Hub course of the semester. The recordings will be available later on via email and also on the C2 Smart website. Thank you everyone for joining us, and we will see you in the spring.
Thank you. Thank you.
Thank you, Jeffrey.
Thank you.
Bye.